Hello, in this short lecture I will give proof of Pythagorean theorem. Uh, Actually, the Pythagorean theorem says that if you look at this right triangle, it says that the square of the hypotenuse c square is equal to the sum of the squares of the perpendiculars. C square equals to a square plus b square. Let's assume that the right-angled triangle, this right-angled triangle ABC, we want to prove that a square plus b square equals to c square. Now we will make a copy of this right angled triangle. We will build along the length of side A. We will draw the side B and raise a perpendicular whose length is the length of the side A. Okay, so in this way, actually, we made a copy of this right triangle ABC. The copy of it is here, ABC. I will prove that these two right triangles actually are coincides. Now we have two triangles ABC on the right side and triangle ABC on the left side. Whose two sides are equal to each other. A equals to A and B equals to B. Okay, we have two sides in these two right triangles that equals to each other, and also the angle between sides A and B in both right triangles equals to each other, and it is actually 90 degrees in both triangles, because in this right triangle the angle that is 90 degrees is the angle between sides A and B, and we actually built this triangle with a 90 degrees angle between side A and B. So therefore triangle ABC on the right side coincides with triangle ABC on the left side according to the rule side angle side. That is to say, if two triangles that have two sides, two triangles that have two sides that are equal to each other, A equals to A and B equals to B, and also the angle between these sides is equal to each other. The angle between A and B is 90 degrees, and so is the angle between A and B is 90 degrees. So the triangles are congruent. Triangle ABC congruent to triangle ABC. And since the third side of triangle ABC on the right is C, then because of the overlap of the two triangles, then the third side of the triangle ABC on the left side is also C, because of the fact that those two right triangles coincides, and this is side C, so it must be that this is also side C, because they overlap. So let's mark the angle between side A and C, the angle between side A and C. Let's mark the angle as alpha, okay? The angle between side A and C is alpha. As we know, the sum of the angles in a triangle is equal to 180 degrees. Okay? Every triangle, the sum of its three angles equals to 180 degrees. Therefore, the angle between the sides A and C will be x plus 90 plus alpha. If we assume that this angle is x, then x plus 90 plus alpha equals to 180 degrees, because the sum of the angles in any triangle is 180 degrees. Yes, so in this triangle we have 90 minus alpha plus 90 degrees plus alpha, but we want to find the x angle. So x plus alpha plus 90 equals to 180. Therefore, x equals to 90 minus alpha. And since the sum of the angle on a straight line is 180 degrees, the sum of the angles in this straight line is 180 degrees, then the angle between the sides C and C in the middle triangle will be, if we mark this angle as y, and the sum of all the angles must be 180 degrees. Yes, so alpha plus y plus 90 minus alpha equals to 180 degrees. So y equals to 90 degrees. Yes, because as you can see here, alpha minus alpha is 0, and we subtract 90 in both sides, so y equals to 90 degrees. So the angle y is 90 degrees. On the one end, the area of the trapezoid, we have here trapezoid. The area of a trapezoid is equal to the sum of the parallel sides. Side A is parallel to B, so it is A plus B multiply the height of the trapezoid. The height is also A plus B, and divide by 2. Or in mathematical notation, we will get A plus B times A plus B divided by 2 equals to A plus B squared divided by 2. Okay? On the other end, the area of the trapezoid is equal to the sum of 3 triangles, yes? So the area of this triangle is A times B divided by 2, and so is the area of this triangle, A times B divided by 2, and the area of the middle triangle is C times C divided by 2. Yes, so we actually calculate the area of the trapezoid in 2 ways. The first way is the sum of the parallel sides a plus b times the height of the trapezoid plus a plus b times a plus b divided by 2, and the area of the trapezoid. The second way to calculate the area of the trapezoid is actually the sum of these 3 triangles, and the area of this triangle is a times b divided by 2, and so is the area of this triangle, and the area of this triangle is c times c divided by 2. So we got here the area of the trapezoid a plus b squared divided by 2 equals to the area of the 3 triangles, that is a times b divided by 2 plus a times b divided by 2 is in total ab, plus the area of the middle triangle is c squared divided by 2, and then we multiply the two sides by 2, and actually a plus b squared equals to a plus b times a plus b, and c squared divided by 2 times 2 is c squared, and ab times 2 is 2ab. So we open the brackets. A times a is a squared, b times actually when we open the brackets, we get a squared plus b squared plus 2ab equals to c squared plus 2ab, and here we can deduct from both of the sides of the equation 2ab, and at the end we will receive that a squared plus b squared equals to c squared, and this is actually Pythagorean theorem. Okay, it is very simple. Okay, thank you very much.